Hello, very good afternoon. Very good afternoon. So today the topic which I've aligned is deploying microservices using GitOps. So this is like uh, not a beginner session, but of course I will try to explain the concepts of what is monolithic architecture, what is microservices. We will look into what is the difference between the DevOps, traditional DevOps, and GitOps. So this topic revolves around cloud native technologies, like cloud native in the sense we do use cloud native in the new architectures like microservices, deploying your application over Kubernetes. So this is where my topic is around. So I will be going to show the differences between the what are the different GitOps tool. We'll go through the Argo CD and Flux CD and the difference between the traditional DevOps and the DevOps tools like Jenkins, Azure DevOps, and the other tools of GitOps like Argo CD and Flux CD, and would then go little demo day is there also scheduled for the Argo CD. I will just walk you through how we will basically deploy the application of Kubernetes using the Argo CD, and I will also give a brief overview because I understand there's a mixed crowd, even people who are going to start their career as well present here. So I will get you concepts clear from the starting point itself so that you can start, deploying your applications over the open source repositories which are available now. So, so this is basically a quick intro about myself. I'm working as a lead DevOps at ABB. I have over 12 years of experience. So I started my career with operations background, and then moved to the subject matter experts, and then basically I've worked in all the levels L1, L2, and L3. Then 2016 is when I started working to the Visual Studio DevOps, which is in 2018, which was referred to as Azure DevOps. So my journey started with the operations background with a Linux system admin in a startup back in 2010. And then I moved from operations background to the DevOps. So here my role is to work with the part of the operations team, leading and working in collaboration with the research and development team, the developer team, to deploy the code into production and maintaining the basically the CI/CD for the organization which I'm working, and also basically working into the cloud architecting, as well as I've worked as a data engineer also in my past roles, and with a keen interest in data analytics and Azure DevOps. This is where my recently role in the company where I'm working. So mostly the tools which we are using is Azure DevOps, and but in this session I'm going to cover on the totally different tool, which is the GitOps, and where I will show the tools. So I've worked in almost all the sectors, manufacturing, and currently my industry is in manufacturing, with industrial IoT. And specifically I'm into robotics division. Like I worked in that. So and that also we are. I'm working with the software developers in streamlining their pipelines in the continuous integration and deployment. So yeah, so basically working with C sharp and worked with almost all the flavors C sharp .NET as well as the Python, where the code resides. So basically then these are the couple of agenda which I'm going to speak today. Starting with what are microservices, and I will go through some of the challenges with basically deploying what are the basic challenges when deploying microservices, and basically I would explain the maintainability part. It's very challenging to maintain the application when it moves from monolithic to microservices architecture. So what is GitOps and what is Argo CD, and what is the difference between, we'll try to see some of the difference between the Argo CD and Flux CD, and when to choose what, and how can GitOps and Argo CD help the deploy your microservices. And then there is a basic demo which I focused on the Argo CD, how to deploy your application using the Argo CD. So that this where I'm going to cover the demonstration of it, and I will try to cover on those aspects as well. So moving on. So when I speak about microservices, because the topic aligns about deploying your microservices using GitOps, so it is very necessary to you to understand what is microservices. So before that, I will give a brief intro about monolithic architecture. So monolithic architecture is something we have a web client, application, and database, right? So typically communicating using a WCF framework, IS. Suppose we have IS website in the application server, and the database we have SQL Server. So we had very tightly coupled applications which we used to have 5-6 years back, where typical in 3-3 architecture, everything used to be dependent on each other, and we have one single repo, mono. It's called mono repo, which is still existing. And we used to have TFS repositories. So monolithic was cumbersome to maintain, very less flexibility when it comes to moving to the cloud. So whether it's Azure cloud, AWS, or Google, it's very difficult to convert the monolithic kind of architectures to the to go into the cloud. So it was getting very difficult. So what happened is then this my concept of microservices came. So microservices are loosely coupled. Applications can be built independently without depending on each other module. Developers don't have to wait for one module to be completed. They can start independently working on the. So a large application is being divided into some small modules. Some is working in the payment gateway part, some is working in the order payment gateway, and then they will collaborate to work, merge their code into the GitHub repositories, and then we'll call a polyrepo concept came. So from monorepo, we have transferred to polyrepo. Polyrepo means the large application divided into small chunks of applications. As you see here, the account service, I just give an online shopping example, product catalog, cart services, and order services. So people will work on their different type of modules. Then the code will be merged to a single base application, which is how the nowadays the e-commerce companies like Amazon, Flipkart, how they work actually. So basically, typically all the e-commerce and all the websites which we are having have moved toward the microservices. Why? Because the scalability microservices offer is very huge. Like the high availability concepts are there, and when it comes to deploying your application to Kubernetes, it becomes easy when you move your application from monolithic to microservices. You can learn more about these differences over any online platform. But just to start with, I just want to have a brief overview, the differences between the monolithic and microservices. So microservices, it's independently deployables, and independently, as I said, it can be independently deployed, loosely coupled. Every component account service doesn't have to depend on product catalog. So it gives the developers the privilege to work independently and not dependent on each other. In waterfall model, in the monolithic architecture, people used to wait for that I'm actually waiting for this model to be completed so that my work would start, because my application is dependent on this developer, so I cannot work on it. So in kind of microservices which we are working right now, it's all independent now, loosely coupled architecture. So this is where the advantages offer. So organization organized around the business capabilities, and then owned by a small team. As you see, when developer starts working on an application, they can start working independently without depending on the other codes, and then they can we will have 4 or 5 teams working on a particular product, and then we merge that code to form into a basically the application. So what are the advantages of microservices? They deliver large complex application very frequently. Reliability and sustainability means a very if you see the how the changes in the shopping Flipkart or then Amazon or any other like We have other websites as well, Go Avivo. So the deals which are coming up for the flights and all. So how dramatically in each day there are thousands of deployment. Each second there are thousands of deployment, and that cannot happen with a monolithic architecture. That has happened through the advent of these microservices and how we have started evolving. Apart from the Azure DevOps and Jenkins, we have also started using the other tools. Yeah.
How about this latest news, right? Amazon is this Prime services are moving back to monolithic.
Yeah, so that's a classic example how they have reduced the. I think because when we have started moving, it's a classic example when companies have started moving back actually from microservices to monolithic. It's not monolithic, but they have what they have done is they have tried to convert their serverless PaaS architecture to basically IaaS architecture. They have moved their workload from the serverless component Lambda architecture to the EC2 instances. So that will give. Actually, when I'm working in enterprise, right, what I have realized, it depends on the use cases. You can't be paying so much for the services which we are not using. In past, there are tons of services which might not be using, and on top of it, the data which is coming in the past services, a huge consumption because the intake of data in could be in GBs, and it could impact the costing as well. So it to reduce the cost, they might not to have cost optimization and to fit into their demands. It is not that shifting to the EC2 is a bad idea. It's a good idea as well because we do have virtual machine scale set there as well. But because scalability still there remains the same. But only thing I think according to the use cases and the needs, everyone don't needs to be in the microservices. So that's how they have revamped their architecture to move from Lambda services to the EC2. So I think that's a classic recent example where for some parts, it's not for all, but for some specific parts, they have moved their services from the but the architecture still remains the same. The architecture has not is not changed. Like the circuit is still on kind of in microservices, but they have moved from PaaS environment to IaaS environment. So there are three different components: IaaS, PaaS, and SaaS. So EC2 moving to EC2 is a infrastructure as a service, so where networking and you deploy your code and operating system also belongs to you only. But in PaaS, it's all belongs to the cloud vendor. So I think it's they have taken the decision based on the use cases. They have the demands, they have elasticity, scalability still there remains the same. It will not impact the performance of what the decision which they have taken. So equal services are there, but only I think what challenge would be there that like uh, in terms of while communicating with the architecture with the Kubernetes, where PaaS services offers more scale, more compatibility in containerized solutions. So there is where because this was IMC as a challenge, but I think that with the AWS cloud, they have more capabilities as well to support. So only the cost optimization and the basically the business use case scenarios, they have shift their services because lots of services come along with PaaS, and the data which the amount of data which is required to retain is huge actually. The amount of intake data in the PaaS services is huge. So in IS, the cost is pretty much reduced when it comes to the costing part as well. So I think that's where they have taken this decision to move to EC2.
To the IS also cost will impact, right?
Cost will impact, and even yeah, even for that also the cost will impact. But I think it's more on basically on the use cases wise. If you see cost of running, because in the IS also, if you see the structure of the we have a pay as you go model. Every company adapt to pay as you go model, and there is a concept in Azure called Azure I think the reserve instances means you buy it for a year, and it will be offer you huge discounts in terms of procuring a VM or a cost. Similarly, we must have a reserve instances concept in AWS as well that will reduce the cost consumption. This is one. Second is pay as you go. Means, see, if your production workload, you can, or a dev test environment, you can stop your workloads over the weekend. That you have full control. You can stop your, typical VMs over when there is for dev test environments I'm talking. So those instances you can stop which we are not using. And pay as you go means whatever you are using based on consumption or the intake of data into your VMs or the instances VM instances, only for those amount it will be charged. For the off hours it won't be charged. But again, if you see, running the cost of VM is also a huge in that scenario. But I think with the pay-as-you-go model and the as in Azure, we have Azure Reserve Instance concept, where we buy a VM for a year or two. It will offer us, but for that also it's a risk. You have to be ensured that the application will be running for 2 3 years. You can't be doing purchasing reserve instances for POCs for doing for if you want to do your POCs and you are buying a reserve instances, it's not a good idea. So I think there is where in production workloads we usually buy the reserve instances so that we can use it for 1 or 2. And in terms of cost, also we will also have a good discount from the cloud vendors. I think for AWS also similar thing would be should be there because I think AWS was the first to introduce on the cloud technologies. So we then I think the Azure and Google have followed some of, but the models of the pricing cost calculations in terms of that. So yeah. This is the some of the challenges of managing microservices. See, I think that's probably the reason where I think the example which we are talking, that's why I shifted to the architecture to IaaS workloads. Monitoring and observability should be there. Continuous monitoring and observability, because when you talk of deploying your serverless workloads on containerized application, or then you need to continuously monitor and observe the things which are happening. And the other thing which I see, the lack of knowledge, skills, and resources. Uh, the community which is there for we have for Azure, like for these, we are still expanding in terms of when I talk about cloud native technologies. But I think even if I talk about Argo CD and Flux CD, it's still CNCF. I think some of you have heard. So it's a Kubernetes. It's incorporating like Kubernetes is a child of CNCF. So even the tools like Argo CD and Flux, they are also under CNCF. So CNCF is an organization which incorporates cloud native tools, which gives standards to these tools so that they can be productized in the market. So these tools are also on CSCF. Problem is what I see challenge, the lack of knowledge, skills, and because not all companies are going for the cloud native technologies. So I think that's where some of the things comes, and building deployment at multiple service in a single pipeline. So like you need to basically either we will see in GitOps, either you need to rely on your code. Your code should have all the components declared very effectively so that it can act as a single source of truth. Otherwise, there would be multiple pipelines for deploying multiple repositories or multiple pipelines for deploying a particular service or product. So that would create, when it comes to merging the code and pushing into the mainstream branch of the Git, it comes very cumbersome actually to maintain the multiple parallel builds and how to do that. So this is also one of the challenges, and the cost of additional environments, like maintaining additional environments, that's also sometimes makes a challenge. And the other challenge is making Kubernetes microservices ready. So see, everyone can deploy any application on Kubernetes, but you after deploying that, there comes lots of maintainability part. You need to maintain the health of your application. You need to see the health of your system continuously. That we will see in Argo City, how Argo City helps in maintaining the health of the cluster and the application which are deployed in real time. And the rollback is also necessary when you see any fault. uh, what I see in traditional DevOps tools like Azure DevOps, the rollback procedure is a little bit complicated when it comes to deploying your application over Kubernetes. The rollback procedure is, you have to define the steps. After defining the YAML, you have to define the steps as well, and you have to configure the pipeline. But in GitOps, you don't have to do it. Your repository act as a single source of truth. So whatever you declare in your pipeline will be the source of truth. And that's where your Kubernetes architecture needs to have a microservices ready. And security and scalability, again, it's a issue which we also need to address. That's some of the challenges which I see in deploying the. And if you on the left side, you could see, yeah, we will see that no going back means rollback. It's sometimes it's kind of difficult in terms of when we say on the microservices and basically the service discovery, authentication, authorization, and extensive logging needs to be enabled when it comes to the managing the microservices. So just want to discuss this so that I can address these some of these challenges, if not all, in the coming slides. This is I've just go a 1 minute walkthrough. So basically, different. This is all you can find in internet, but this is like different definition given by different people. So based on their experiences, but I would say GitOps is the infrastructure as a code deployment tool. It is a declarative. So there are two parts when you say DevOps tools, Ansible, Chef, Puppet, or you would say Terraform or any of these tools. These are categorized into two parts: declarative and imperative. Declarative means whatever you define in your pipeline, it will be you choose what you want in your infrastructure. Suppose you want Azure blob storage, you want a function app, you want a basically you want a Kubernetes environment cluster. You need to define what you need. So that's a declarative part. Even the Terraform tools like Terraform and the even the GitOps tools like Argo CD is a declarative. So you define what you in the new tools like basically I work more towards the infrastructure as a core tool. So that's why usually working towards the declarative tools like Terraform, Pulumi, and the Argo CD as well. So you means declarative means you define what you want basically. And there's another concept of imperative. So you can also check that out as well. So the core difference which I see, which I want to discuss, is like uh, is that the GitOps allow teams within the organization to manage and deploy changes to infrastructure using the Git as a single source of truth. So as I was saying that when I say upon the GitOps, so everything has defined declaratively in your Git repository, which is acting as a single source of truth. You don't have to go anywhere. With your Git, you can deploy a full stack application, provided your application which is committed in the Git repository is free of errors and is validated. So getting GitOps, what it feels like, you don't have to go to external tools. It's all web based. GitOps, the GitHub Actions flow, GitHub Actions, if you have heard about, it's a workflow which is defined. It's all in the web. You don't have to go to another tools. And if you go to Azure DevOps, there are extensions available. For Kubernetes, you have to install the extensions. You for installing the Docker, you have to install a market. You have to go to marketplace and install the extension before using them in your pipeline. But in case of GitOps, you don't have to do that. It all will be taken care by the tools, GitOps tools. And only you need to make sure that your Git is having the deployable application. Other things, managing the extensibility of the external tools or the third-party tools integration, Grafana, or all those things will be taken care. You just have to define those modules in your YAML pipelines or Grafana or Prometheus, you don't have to install from outside, like in case of Azure DevOps. So that's where I see a difference. So everything is in the Git, which is acting as a single source of truth. While on DevOps, it's most apart from CI/CD, it's basically the collaboration tool between the development and the operations team. It offers Azure boards, extensions, and all those things as well. It's more of in Azure DevOps we can do a lot of things in terms of collaboration as well. But those things can wiki based, all things can you maintain in the GitHub repository also. You define your README file in your repository, and you can do all those things. So whatever even the tracking of your work items in the Azure boards, we can do in the Git flow as well. So that's the core difference which I see between. But now we will also see some of the key differences when it comes to the GitOps from DevOps. Yeah, I think this can just go through once. So well, tool-wise, if you see, in DevOps, we have tools like Jenkins, Azure DevOps, and along with the configuration management tool like Puppet, Chef, and Ansible. While in GitOps, we usually focus on Git versioning control system and other tools for the Kubernetes separate CI/CD we can configure. So when I say on this terminology GitOps, so it has to more to do with the two things: infrastructure as a code. Second, deploying your serverless applications to the Kubernetes. So it eases the deployment procedure of deploying your application over the containerized solution. In terms of flexibility, we have better flexibility in terms of the other tools of DevOps. We have a lesser flexibility when it comes to GitOps. Only I think flexibility offers in terms of deploying of workloads in the Kubernetes. So then we have very frequent deployments can be done with the traditional tools, Azure DevOps and Jenkins, where a GitOps works on different principles. It works on accuracy and precision. Your code should be as accurate as enough. It should be defining the steps. Declarative means you should define your steps. So it focuses on the aim is altogether different. To focus on accuracy and precision is what GitOps focuses on. Moving on. Yes, so now we have so Ergo CD. So now coming to the Ergo CD, where I have also have one of the demo to show. So Ergo CD is a declarative again, and GitOps continuous delivery for Kubernetes, and it basically it's a pull based. So we have two types of models: pull based and push based. So Ergo CD works on pull based mechanism. It pulls the recent changes from your GitHub repository and then pushes into the basically you have the manifest file for the Ergo CD as well. It pulls the latest code from the GitHub workflow, whatever you define in your Git, and then it implements the infrastructure into the infrastructure as a code tool using the Ergo CD pipeline. So GitOps is continuous delivery tool for Kubernetes, which it has a very good UI. So, but there are two ways of doing Ergo CD GitOps, DevOps basically. Either you can do command line or you can do through UI. I will show through the UI this time, but CLI, I have configured this already a setup. You can you can either continue to work on the CLI Ergo CD, but if you see the UI part of it, it's very much flexible, and it's you can see how the changes in real time, how it's happening. So then when it comes to this is the tools which the differences between the Flux and Ergo, both are used equally, but in terms of the community support, we have good community support for Ergo CD. In terms of the contribution and collaborations for the different developers, they keep on contributing. So this is the different. Basically, it was developed by Waveworks, whereas Ergo CD was first termed in by Intuit. Intuit is also an organization who has developed this, and then now it has been under incubation of CNCF, Cloud Native Foundation that supports Kubernetes. Now CLI first, Flux purely works on the CLI based approach, command line interface, whereas Ergo CD supports both UI as well as command line. So it supports RBAC, and Flux uh, supports the rollback procedures, the RBAC role-based access control procedures. And whereas Flux I have not seen used in a single sign-on, means single sign-on is well integrated with Ergo CD. Single sign-on is a concept of Active Directory. Like with your organization ID, you can very easily basically integrate your Active Directory of your company's enterprises to Ergo CD as compared to the Flux CD. And when it comes to the organization support, it supports multi-tenancy, and whereas Flux also supports multi-tenancy. And when it comes to the Helm. So to deploy the Kubernetes, there is a Helm is a deployment package manager which is used, which is all supported by Helm customization, and this is all supported by Ergo CD, and pretty much same features in terms of when we go for Flux CD as well. So in Ergo CD we have manual commits and sync to update. We will see in the our demo as well how this application will manually sync and talk to the cluster which we have deployed. So this will auto sync will happen when it comes to the Ergo CD in the UI which we will cover. And automation of container updates can be done using Flux CD as well. So yeah. So this is one of the yeah. Yeah. Okay, so this is so I have more to show on the demo side as well. So that you can start working on it, because it's not that tough to implement the it's not that tough to implement this. You can go ahead and implement this Argo CD, and I will also give you the links to deploy the application through Argo CD. Well, you can fork the repository of the source code into your personal GitHub account, and then you can start working on different application. Sample code base is given already, and which you can start implementing. So even I'm giving you the tools which you can start using in your local laptop or PC. So first, which the demo, I have 6 tools as a prerequisites. First is Docker Desktop I've used. Docker Desktop, see, in enterprise, never install it until you don't have license for it. Means your organization laptop don't install, because for the organization, it will ask for license. But for your personal use, it is very good to use when you want to learn Docker containers. It's a very good tool to use, Docker Desktop. We will see that as well in my system, how it is, because you can learn Kubernetes without even deploying onto any cloud. That's why it's called cloud native. You can run your one node cluster of Kubernetes on Docker Desktop. So we will the version which I'm using is version 1.4.18. Kubernetes I'm using 1.25. That is integrated with the Docker Desktop version. So that is the second thing. Third is the WSL. So when you are working on the Windows environment, this is a Windows subsystem for Linux that will make your basically it's available in the Windows Store. So Windows subsystem will for Linux will enable your machine to act as a Linux command prompt. So you can execute, have a different flavors, whichever operating system you want. You can install that Ubuntu, Red Hat, or CentOS, and or any operating system. You can install that WSL Windows subsystem for Linux version 2. So that is this helped me to run my container workloads, to deploy the application, to deploy the containers in a Docker engine. And then I will show how I integrated my WSL to talk to my Docker desktop and to talk to my Kubernetes clusters. So this is the integration which I did. WSL is the component for it. And Ubuntu flavor, WSN, I'm using Ubuntu flavor 22.04, which you can use any flavor. Argo CD, I'm using the latest one, which is 2.6.7. And then there is a tool called Chocolatey for Windows. It's a package manager tool for Windows. So which means it eases the deployment basically. It's a package management tool. Anything like Nginx server or anything Terraform or you can install any extension Azure CLI very easily using the Chocolatey for Windows. It's a package manager tool for Windows. Now, we'll just quickly go through the demonstration part. So when I do have this version of Chocolatey. So how just wanted to show how Chocolatey basically works. Chocolatey is a Windows package manager tool. You can install your basically Nginx and anything which you can upgrade install. So basically it will install all the dependencies. I think it's not showing my current screen. So I think it's
Stop sharing and share it again, maybe.
okay. Yeah, let me. Yeah, I think I made some mistakes. Okay. No, it's the entire screen. Is it visible now? Okay. So that's okay. I think that's okay. I got it. Yeah. Thank you. So now I will just show how this works. So I have installed this Chocolatey for Windows Package Manager, and this is how it works. It installs all the binaries and applications. Uh, it's install all the, if you see, this is the way of how it basically works, is installs all the binaries. And this is how I've installed WSL in my system, Docker desktop, everything I've installed using this Windows, this Chocolatey package manager. So just this is wanted to show and how this is working. Now the second prerequisite tool is this is visible, right? Okay. So this is the Docker desktop for Windows, and this is where this is also as applicable in part of my demo, which I'm planning to show. So this is some of the options which you can install Docker desktop right away and start using it and deploy your code to the basically the you can run your containers, you can create images. Uh, and then there is a account which dockerhub.com, dockerhub.io. You just like GitHub repository, it is also like our source code. Dockerhub.io will store the all the images, application images, Nginx, and all the different images. It will show. Create your account on GitHub on Dockerhub.io, and then it will be well integrated with. If you see, I'm already logged in with my account, which is which is this one. I have already logged in, and I'm using the desktop free version, which I can use as a personal account. So these are the settings which you can use for integrating, for making my WSL, which is the other. This is my WSL. I just wanted to show. This is my Windows subsystem for Linux. This is, if you see, and if I go to the WSL, I type WSL, I do have WSL. This is a Windows subsystem for Linux. This is for executing Linux-based commands. And how I have integrated, built the containers and deployed application is I have integrated this WSL with my Docker desktop, this particular using this option. When you do first time, it will be enabled. As of now, it's grayed out. So using you have to use the use WSL based engine to talk to for your WSL to talk to the Docker desktop. This is needed to deploy your application or containerize your application. Then it comes the resource. Just giving you an overview of it, different options. This is where I have enabled the settings of the Ubuntu 22.04 as a kind of setting. See, there are two versions which I've installed my machine, Ubuntu and Ubuntu 22.04. This is how you need to enable it. When you install enable, you have to right click on the enable integration with my default WSL distro. Distro is nothing is nothing but distributed operating system. This is what how I integrated. This is a typical Docker engine which is behind the scenes running. Kubernetes version which I'm using is 1.25.4. That is aligned with my this Docker desktop version 14.18. If I upgrade now, this version will change. So there is already a Docker desktop market which is associated with it. So now we can also upgrade it. And then when it comes to extensions, this is how you can enable Docker extensions and container instances. And then we have not only this, I think we have a good learning when it comes to the implementation. We have a good learning Kubernetes engine. Uh, So when I go to cancel, right? So this you see containers, these are my containers already I've created images. These are the container images deployed as part of this deployment. And these are the container instance volume. Every container instance has some volume inserted with it, which you can clearly see here. And the beauty of Docker Desktop is you can analyze your containers when you are deploying it. So you can real time, you can check what is being deployed and what are the volumes being procured at real time. And then we have dev environments. So yes, this we can create your own environments, and this is where you can start, developing your application, containers application by creating a dev test environments in your local PC. This is what even the developers do while moving their before moving their application to cloud. If the cloud they are not getting the right resources, they are not completely blocked. They can start working using Docker Desktop. So that's what but it depends organization to organization. If they have licenses for one or two developers, the developers are completely not blocked. They can start working, but only flaw is like it's only for the POCs Docker Desktop. This is like I have not deployed it on top of cloud, but because I want to make this session more cloud native oriented, so that's why I've used all cloud native tools here. And then this is a very good learning resource which you can use Learning Center. This recently been introduced by Docker Desktop. And see, you can deploy all your application containerized Node.js, Python, Go, Java, and C Sharp. These are the builds you can start learning and exploring yourself. Like you can go hands-on. All the these are the some of the community available which you can start working on it. So having described on the Kubernetes on the Docker Desktop, and these are the some of the images which I've running. So now I will just try to move my the demo towards the these are some of the prerequisites which were required to install, which I've just explained. And now I will be moving towards the real demo and how I've implemented all this. So this have pre-configured steps which are pretty much available in the this is getting started with Ergo CD, which you can work. This is could be a starting point when you're working in the GitOps, or you were interested in working or exploring more on this technology. Only so you need to have kubectl, kubeconfig already integrated, and which I have done using this particular integration of the Docker desktop with the Ergo CD, which I will show you through the UI of Ergo CD how it looks like. So how it's done, right? This is when you deploy your application. So this is where let me go to the Ergo CD user interface. So yes, this is how typically after the deployment, how it looks like. So this is like the basically the Argo CD which I've configured for my local host. So you can manage. I will go walk you through different options which I was speaking about. The health status, the rolling back feature, how easily it's available. This is one of the application which I've just tried to deploy it, which you can get the code I will give. Not this is the guest book application which I've tried to deploy it over on the one node cluster running in the Docker desktop, which I have just shown the Kubernetes engine, which is running. So it's all communicating with my Docker desktop, engine. So this is the application which I have deployed on and if you see the different functionalities, you can sync your application according to the clusters. Different application, your whatever manifest is being deployed, you can easily sync your application and basically to know the state where it is right now. So you can sync your application according to the needs. History or rollback, if you go, you can see what are the different times when it is very easy to scroll and go through what changes have been done previously in this particular application. Irrespective of any developer or anything, you can just check the changes out of it. And then if you see syncing, this application is already in sync, and these are different syncing options available, like prune list and respect ignore differences, or this is the guest book UI. This is the application name which I have deployed, and this is the any sync status. What is the sync status? If you see, this application is synced successfully with my clusters, and this has been deployed, and this is where it's been guest book UI, it's been used. This is one of the application. And now when you go to the repositories, you see as of now there is no repository associated with it. But if you recognize, these are the different type of integration which I have done with this Argo CD. Big bucket, GitHub. Of course, I have integrated my GitHub, the guest book application. It's there in the GitHub, and GitLab. These are the integrations which are already there, or might have installed. So that's why they are visible here. These are source of truth, the repositories which are references here. And then we have clusters. I have configured this Kubernetes. So whenever you configure an application, you have to define the source and destination. So source is your GitHub link, which I will just show. This is destination. I have deployed over a Kubernetes default work namespace with a name as in cluster. And this is how the cluster looks like. And after that, there is if you can configure different projects. I have not configured different project. There's a default project which is going on. So this is the default setting has been taken. So accounts, again, only I have configured one account, which is the admin account, which we can use here. And then we have the appearances, which you can actually show the enable or disable the logo. So this is where you can explore more. Even in the tools which you have deployed, you can explore more about on this particular thing. So this which I have deployed, this is the UI which has been configured, and the steps which I have taken to install this is I have configured some of these steps, which which you can also read through the documentations of the I think which I was just referencing it previously. So this is the installation part, how you can install first, and then you can start working on this. And this is the GitHub repository link. Let me show. I think I have in my slides. So this is the GitHub repository links for deploying the basically the yeah. Yeah, so this is the some of the Argo CD examples which you can. So this is the Argo CD examples, out of which you can. I have taken the example of this guest book app, which is also a this is an application which a Hello World guestbook application which is deployed over a plain YAML file, and this is based on the basically this is what I have deployed in the cluster node, which and this is the YAML file which is defined. If you see, I have not gone to any other extension tool. I have not installed anything, right? Like any extensions. It is all through the GitHub. This is the source, and the destination is my Kubernetes cluster, which I have been defining. So source is this particular application. This is the YAML file, which is I've defined for this application, and and uh, and yes, this is the UI part of the YAML file, and then we have I think this is where these are command line tools which I have executed, and let me show through the slides because this is I have just recorded these steps in terms of, so this is like some of the port forwarding which we can use to basically run the local host in your respective machines. So yeah, this particularly I have captured just to show on that. I'm not able to resume this on the slide mode. Okay. So this is where I think which I have showed previously. There was no application. This is how it will looked like, and after that, this is after the deployment. Uh, I have added my cluster node using these commands: ergo cd cluster add docker desktop to make sure the my Docker desktop is integrated with my to talk to Docker desktop. This is the commands which I have used: ergo cd cluster add docker desktop, which is what you were seeing in the Argo CD, the platform as well. If you see here, so this is so Docker desktop. I think app details. If I go, so if you see here, we do have the this is the destination which you are seeing here, and this is the manifest file which it will come. So this is the manifest file which it's so this all can be defined and can be seen in the detail in the application. So if you see the name of the guy is also there, we have taken the repository from the Intute, developed by Intute, this Argo CD. So this is about configuring the. I have created the namespace Argo CD. A namespace is created in Kubernetes to differentiate the deployments, so that there's a default namespace as well. But for Argo CD, I've created a different namespace. It acts as a different containers. Basically, so as not to club with the other developers' work, Argo CD have created different namespace, and all things I have deployed there. So this is where it is like, and then Argo CD just to get the status of the health using the Argo CD CLI. This is the screen for that, and this is the same screen which I have used here to get the status, and to get the status of. We can also check the status through basically. So this is this is the command which has been used is Argo CD apps in guestbook, and it will show the status of your nodes and the deployments. What is the status? It's healthy, or whether the application is synced. If you see the last message is synced or not, so you can check the status here. This is what it's been reflecting here, and this is the UI part. And and this is before ending up this, I just want to show the containers which are deployed as part of this Argo CD, which we can see as a part of real time. When I search for Argo CD, you can just go and see there are almost 19 items being deployed, and each are having their own purposes. But some of them we've just procured yesterday. This is as part of the deployment, the UI which you were seeing. So first I have deployed the namespace, then I have defined the source and destination. Source is the GitHub link which I have shown you previously. Destination is my OneNote cluster. Then I've registered this Argo CD. These whatever you are seeing are the mix of Argo CD manifest files as well as the application as well. Guest book application. So that's why these are many. You can see the container images which are there. So. And I think I have deployed Flux as well, but I don't have Flux demo ready right now. But this is I have deployed did an R&D on this Flux CD as well. So the beauty of using when you are starting with the container applications, right? I would say you can start using Docker Desktop, WSL, and these are some of the tools. Chocolatey for Windows, you can start working on it from now only. So you don't have to, unlike Azure DevOps, you don't have to first, you have subscription. You need to have a subscription, and then you need to start a free trial. But this is something handy tools which are coming up, and you can do starting from the day one. Anything. This is some of the alternative tools for, and this best suits for the Kubernetes deployment. And you can go and see the details. What are the logs which are coming up, and the stats of images. Also, you can see the detailed images which I've deployed Argo CD as part of it. This is the entire image vulnerability. Also, it will scan and give to you the Docker desktop. So these are all the basically the commands which are mentioned in the container, in this containerized image. So this is the syntax also. It's defining the syntax also, like how we have used different basically the commands. And this is the add file is nothing but it is trying to add the files from the GitHub repository, and what are the different codes available. You can check these things. And yeah, I think that's pretty much on the on this GitOps part. I'm open to questions if any.
So basically, you mentioned it's a alternate for Jenkins, right?
Yeah, it's a, yeah. You can use alternate to Jenkins or your DevOps also.
It's a continuous delivery tool, and Jenkins, if you see, you can do integration as well. So is there a possibility to run like integrations like unit test cases or E2E test cases in this Argo CD?
You need to define all these unit tests and test cases in all things in your Git repository itself. Basically, after doing those test cases, see, every developer or every tester would do their write their test cases, and then after they have done the test cases, then they would use the Azure test pipelines and commit that particular code into the repository. Similarly, when you do that thing, you have when you have developed your test cases, you commit that in your define push that code into the GitHub repository, and then when you define that. And you define in your YAML also to call that particular test cases, it will execute that one. But because here difference is everything you have to define in the GitHub repository. Unlike the other things, that is why for the complete CI/CD package, for the deployment info, because it's a CD, it's focused more on the CD part, deploying. So for the integrations, you need to basically commit your test cases in the GitHub. It should be there in your GitHub. Otherwise, to install, have integrate from a different, unlike the Azure DevOps or Jenkins, you have to install externally, and then it will pick up the Azure test pipelines. But here the things are different. Integrations are not so seamless because this talks about the deployment part. Ergo, that's why its name is Ergo CD. So if you have to define integrate the test cases, you have to define in your single source of truth, which is the GitHub repository, so that it can take the test cases. Integration might not be suitable more, but I think for the infrastructure deployment, infrastructure as a code tool, this is where the use case fits in Argo CD. But for test cases, whatever you want to do, you have to define in your GitHub, and then Argo CD will take this up and test your application as well. But that you have to define and take care in the GitHub itself. You can't be running in like in Jenkins or I think in Azure we have Azure test pipelines also. We can't do that one here. You have to define in. If you're not defining, then it won't take the test cases.